Today, we're diving into a pretty wild idea. What if you could find the blueprint for a futuristic computer, hidden inside an ancient sacred text? I know, it sounds a little out there, but stick with me and let's see how this incredible thought experiment unfolds.
So this is the central question, right? The whole idea behind our source material boils down to this. What if you could read a text like Genesis, but instead of seeing theology, you saw the engineering specs for a light-based or photonic computer? It's a really mind-bending exercise, connecting the ancient world with the distant future.
And this quote just gets right to the heart of it. The idea is to approach these texts as a design brief, almost like a product requirements document handed down from some kind of divine engineer. The goal here isn't religious. It's to see if these powerful ancient metaphors can inspire a totally new way of designing complex systems.
All right, so here's our roadmap. First, we'll talk about the basic idea of using Scripture as a blueprint. Then we'll look at the high-level architecture of this conceptual processor city. After that, we're going to zoom all the way down into a single cell, check out its brain-like memory, and see how the book of Genesis could actually be its boot sequence. And then finally, we'll zoom back out and talk about the bigger picture.
Okay, first up, let's really get our heads around this approach. The idea is to just set aside the theology for a minute, and instead hunt for engineering principles. The text becomes this rich source of metaphors for things like system variables and design constraints. So a phrase like, "let there be light," well, that becomes the very first line in your requirement stock.
So how does this all build up into a high-level architecture? Well, the concept is called the New Jerusalem Photonic Processor, and it's a system where light, sound, and magnetism all interact inside this massive crystal structure inspired by the city described in the Book of Revelation. And here is where the analogies get really, really concrete. The Lamb as lamp, that's reimagined as the system's central light source, like a laser. The 12 foundation stones become 12 different spectral bands, basically acting as optical filters. Seals and trumpets are interpreted as the actual commands in the boot sequence, and the Tree of Life provides the physical layout, the whole branching structure for all the memory and processing nodes. Okay, so from that massive city-like structure, let's zoom way, way down to the most fundamental building block, a single hexagonal processing cell. And the physics of how this tiny little component is supposed to work is just incredible.
Now, the shape itself was chosen for very practical engineering reasons. A hexagon, as you probably know, allows for perfect tiling, no wasted space at all. And by inscribing a Star of David inside it, you create these natural pathways and nodes for light and energy to travel. So this sacred geometry actually becomes a super efficient engineering topology.
But how does a single cell translate between all these different forms of energy? Well, the key is something called the piezoelectric bridge. Think of this as a material inside the cell that acts like a universal translator. When light hits it, it creates an electrical charge. When you apply electricity to it, it vibrates, creating a sound wave or a phonon. It's the physical link between the worlds of light, electricity, and sound.
So here's the basic workflow. Step 1. Light carrying information enters through gates at the 6 points of the star. Step 2. That little pulse of light hits the piezoelectric material and gets converted into a tiny electrical signal. And then, step 3, that signal is used to write a piece of information into one of 10 small memory rings that surround the cell's center.
All right, now let's zoom in even further on those memory rings, because this is where the design gets really wild. The goal here was to create a memory unit that functions just like a key component in a modern AI network.
This comparison really makes it all click. In AI, there's a special type of memory called an LSTM node, and it uses abstract concepts like an input gate or a forget gate to manage information. Well, this processor design creates physical versions of those exact same things, using specific optical couplers and magnetic fields to do the job. It's a one-to-one mapping.
So, check out how this memory works. First, a specific acoustic tone, think of it as a trumpet, opens the input gate. Light then comes in and writes information to a magnetic domain. Now, that magnetic state holds the information without needing any power. That's true non-volatile memory. To erase it, a different tone opens a forget gate. And finally, a third tone opens the output gate, which allows a gentle beam of light to read the state and send it on its way.
Okay, so we've seen the hardware. It's complex, it's fascinating. But how do you turn it on? The source proposes this incredible idea, using the first chapter of Genesis as the literal boot sequence for the entire system.
And just look at how cleanly this maps. Day 1, let there be light, is power on and system clock initialization. Simple. Day 2, separating the waters, is creating distinct software layers. Day 3, the appearance of dry land, is the physical patterning of the silicon substrate. The sun and moon on Day 4, they become external timing beacons. And Days 5 and 6, the creation of animals and humans, represent deploying autonomous software agents and the human operators who oversee it all. It's just a remarkable parallel to a modern engineering startup sequence.
All right, let's zoom back out and talk about the bigger picture. What are the key design principles that emerge from this whole exercise? And maybe more importantly, what's the right mindset to even approach something like this?
You know, it turns out that reading the text this way uncovers some pretty timeless engineering wisdom. You get principles like a proper boot order, separating different system functions, building in layers, managing signal versus noise. I mean, in the end, these aren't just technical specs, they're universal rules for building robust and resilient systems.
And the source material is very, very clear on this point. This is not a claim that Scripture is some kind of literal engineering manual. It's a heuristic, a creative exercise using ancient metaphors to inspire new designs. And it requires a sense of stewardship, of humility, and a clear-eyed view that this system is a tool, not an object to be worshipped.
This whole thing leaves us with a really fascinating final question. If one ancient text can inspire such a detailed blueprint for a future technology, what other sources of ancient wisdom, myths, philosophies, other sacred texts are just sitting there, waiting for someone to come along and read them with an engineer's eye? Something to think about.